Hello, this is Dev Tigris, and welcome to my JavaScript HTML game development tutorial number 9. I'll start this tutorial by going over some of the things that we'll see in this tutorial. We've already started a JavaScript engine for an RPG game, but as soon as we started drawing sprites, there were many new opportunities created for improving our sprite rendering engine. And so the first thing that we will take a look at will be resolving counter conflicts between animated sprite objects that we had seen in my previous tutorial. We'll tackle this task by pre-creating about 32,000 animation counters. We'll reset global animation counter on every frame in our game loop. And every time draw method is called on any of the sprite objects, we have to increase the global animation counter. This way, we will use a unique counter for each sprite. This will resolve our animation troubles from our previous tutorial. In order to make all of this a little simpler for us, we'll create a new animation JavaScript object. And in this tutorial, we'll also be upgrading our game engine by adding two more components, animation.js and spritesheet.png. But for the most part, this tutorial will be all about improving our Sprite.js function containing the main sprite object. And finally, we'll reuse the sprite sheets without having to reload them more than once, which was also one of the problems we faced in our previous tutorial. And I think it's time to resolve that problem. The main theme of this tutorial is drawing and animating sprites using our upgraded engine as we move closer to building an actual video game. And I'll briefly state here again, using global animation counters, we will avoid animation collisions as seen in our previous tutorial. We'll add the new sprite sheet object, which will be located in spritesheet.js component. And we'll start reusing sprite objects, such as dog instance or any other ones, with a cached sprite sheet image. That means that we'll only load the sprite sheet image once, and it will be freely available to any objects in the future without having to load it from disk again. Now remember that originally we had a sprite object in our engine, and that sprite object basically contains an image, and that is the sprite that is usually rendered on canvas. In this tutorial, we'll upgrade our RPG engine with a new object sprite sheet, and we'll attach this sprite sheet object to our sprite object. The sprite sheet object that is now part of our sprite object will also contain an image. And so now we have this sprite object that can choose between which image to use. As I continue explaining this diagram, I'm sure it will make a lot more sense. As you may remember, our original sprite object contains the draw method. And this draw function in my previous tutorial worked with the image here that is originally attached to the sprite object. But what's unique about this new way of using our sprite object is that now the draw function will automatically choose the image that is available at that time. In other words, if our sprite object was created with the sprite sheet, then it will use the image from the sprite sheet. But had it been created using the original constructor, it will use that image. This process is automatic. Here I'm only explaining how the code will work, and we will never have to think about any of this. But the draw method does not really care which image will be loaded. It will simply allow us to draw anything the way we want it, no matter how the sprite was created, with sprite sheet or without it. To further extend that flexibility, this draw method will have several different ways in which it will allow us to draw sprites. And of course, there's the regular single image sprite where the original sprite image is used. But we'll also have single frame drawn from sprite sheet, which is this image right here. And again, this process is automatic, but the draw function will give us the proper interface for drawing all of our sprites. But of course, drawing single sprites or single frame sprites from sprite sheet is not everything that we're looking for here. We'll also need to support animation. And in a lot of ways we already do, as has been shown in our previous tutorial, but that was very simple example. And again, we ran into this animation counter conflict that this new code will help us resolve, and additionally make more space for various ways of calling the draw function with rotations in mind. So probably the most complicated part of this tutorial is upgrading the animated sequence draw function. And as I mentioned before, we're going to be adding animation counters that are only available to each specific single sprite, rather than using the same counters for multiple objects, which is what created that collision. So creating these counters in global space in our JavaScript application will allow us to resolve that conflict. Let's represent that conceptually. So here we have 32,000 global animation counters. In our code, of course, it will look something like this. So all you have to do is imagine an array with 32,000 entries. Each one of these entries will basically be a unique animation object. This animation object will be defined in our new component that we're going to add, which is animate.js. Each one of these index entries, 0, 1, 2, 3, and all the way up to 32,000, will contain this animation object. Each animation object has 3 counters. This is really the minimum number of counters that we need to do traditional animation. And you really can't get away with anything less than 3 counters, because we do need our delay, which will delay our animation. We need our index counter, and we need the current frame, which will determine the final current frame of currently animated sprite. And also, once we implement these counters, in addition to that, we need to do some basic animation maintenance in our main game loop, and also within the draw function itself. There's one thing that comes to mind. We need to increment global counter index every time the draw function is being called. That will allow us to move to the next index in the array. If we don't do that, we'll simply be stuck with this first one, and that's pretty much the example from our previous tutorial. But the whole point is to expand and use multiple counters for each sprite that is being animated at the same time. And I think 32,000 counters is a pretty good amount for almost any game. And you can increase or decrease this number according to your needs. Of course, what this means is that you can have up to 32,000 animated objects on the screen using the same sprite instance, such as dog, and without running into any problems as far as animation counter collisions go. So this definitely takes care of that in a slightly elegant way. On each frame in our game loop, we need to reset animation counter globally. This will allow us to start from 0 every time we start a new frame of animation. I created a function for that reset animation counter, but really it's as simple as setting one variable to 0. And finally, all of this will give us this really neat interface to draw and create sprites from sprite sheets or simple images. For example, first we can create a sprite sheet, dog, PNG, and then we can pass it to the sprite object. Then every time you call dog, it's always using the same sprite sheet, so we don't have to reload it every time, just because we have to draw multiple dog objects using the same instance. And another way of using this new technology that we're developing for our engine is that you can always create another instance of the sprite but pass it a file name instead. And even in this case, if you replace dog2 in here, all of these functions would continue to work like nothing has happened. So doing this will retain animating sprites the way we started them in our previous tutorial, but also adds this all additional flexibility. And this creates a really simple interface that will allow us to forget all of this complex code that's running on the inside and simply focus on loading our sprite sheets and sprites from PNG images and pretty much in every way possible that we might need for developing a video game. For example, draw method will simply draw the sprite with its original dimensions, such as 32 by 32 pixels. Draw XY and passing to it the sequence for the animation will draw an animated sprite automatically. Draw with XY and a digit, such as 17, will only draw that single frame from the sprite sheet without having it animated. And then at the end of this tutorial, I'll add a couple more functions that will allow us to rotate the sprite around its center. And the last one will allow us to rotate an animated sprite. So again, you would pass the rotated angle to the function and simply pass the sequence for the animation, and it would beautifully rotate and animate at the same time. I decided to add this function because someone in the comments in my tutorials on YouTube suggested that I do this, and so that is why I created it. I thought it was a great idea, and please send me more suggestions. Maybe in my future tutorials I'll definitely add those things into our engine. I certainly don't think that I can do all of this on my own, and your help is always appreciated. I do believe that we have covered just about enough theory and we're ready to jump into the code. As far as the code goes, I'll start roughly in the same place where we left off in my previous tutorial. Here we have an animated dog and we can control it with arrow keys. Notice that here we're still using the old draw animated function, which looks like this. And here you'll notice that we're still using the same counters for each sprite, which are defined with this keyword. And previously in our code, this is where they are defined. And the purpose of this tutorial is to rewrite these counters and put them into an animation object. Notice that the only other thing that I added so far to the sprite object before I started recording this tutorial is the definition of the sprite sheet, and it's currently equal to null. Within this sprite sheet, this is where the second image will be stored that we had seen earlier in my diagram. As you can see, at this time the old and the original image object is stored within the image property here of the sprite object. So let's put them together. These are the two image files that we'll be working with. And of course, the actual image in the sprite sheet object will be located within the object itself. And I'll show you in a second how that's done. Let's add a new JavaScript component to our RPG engine and call it spritesheet.js. The spritesheet object definition is actually very simple. As usual, we are creating a constructor, and it takes a file name such as a PNG image, just like the sprite object. And within this sprite sheet object, we need to define two things. The first one is, of course, that secondary image. And JavaScript has an image object already prepared for us. So we are simply using what's provided by JavaScript. And src, we need to apply, or assign rather, the file name that has been passed into this sprite sheet constructor. And this is our entire sprite sheet object. Again, this is just an alternative way to store a secondary image within our sprite object. Now let's go back to the sprite object that we have so far. So what we're trying to do here will look something like this. Notice that we have just added a sprite sheet object, and from now on we can simply load the image into that sprite sheet object instead of how we usually do it with the sprite object here, loading the dog. And so what this gives us, it gives us the ability to create a sprite sheet from one independent PNG file and then create a sprite, but instead of using the file name, we can use the sprite sheet that has just been created. And as we have just saw, the sprite sheet only contains an image. And so what we're really doing is that we're giving the sprite an alternative source for the image. Everything else will remain exactly the same. Doing it this way will allow us to use multiple sprite sheets for different characters, or even use the same sprite sheet to draw multiple objects using the same instance of a sprite object. And again, the reason we're doing this is because this gives us a really good and flexible way of loading images in all kinds of different ways. And we're not wasting any memory or loading multiple sprite sheets more than once. Okay, so we got that out of the way. And now we need to apply some of those changes to our sprite object, because at this point it only knows how to load from a PNG file. So let's add functionality to it into its constructor to enable it to attach a sprite sheet as its image source. In order to do that, we really need to change only one thing. And before we do that, remember that because this is a constructor function, every time we create an instance of a sprite, all of this code will be executed. Not the functions, but the code here will act as the constructor for that object that we're creating. So all of this will be executed and the function will be attached. So we can think about this as if we're in a constructor for this object. And having said that, let's implement an additional else statement. And this will allow us to load the same image from sprite sheet rather than from a file name PNG file. And we can do that right here. Load from sprite sheet. Notice how the previous one is simply loading from the image. And in order to do that, we call the load function, which is described here. And in order to load an image, all we have to do is just what we did in the sprite sheet object. Create a new image and assign file name to source of that image object that was just created. And so because at this point we probably would already have our sprite sheet created, all we have to do is check whether instead of a file name in PNG or some other format, instead of an actual string, we received an instance of sprite sheet object. And so how do we do that? We do that using JavaScript's native instance of keyword or operator. And all we have to do really is to check whether fn is an instance of an object called sprite sheet, the one that we have created earlier. And if it is, we need to add an else statement so that it's not being executed at the same time. And so if fn is an instance of sprite sheet, then we need to do something special. First, we need to take this property that we have created earlier and assign fn to it. So now we have our sprite sheet object within our property called sprite sheet. And so had that been the case and the sprite sheet object had been passed into our sprite constructor, we also need to rewire the main image that now belongs to the sprite. And we simply need to take the image and make it equal to the image in the sprite sheet. And it's done like that. And as you remember, the image is really this image here in the sprite sheet, and because we have loaded it from the file name, it surely does contain that PNG or whatever file that we had earlier. So we're going back to sprite object, and this is pretty much how you add that functionality for loading from sprite sheets. The only thing that's missing so far is the addition of the sprite sheet component into our base code. So let's go ahead and do that right now. We need to add spritesheet.js and make sure that right underneath it we have the Sprite.js, because as you may know, Sprite.js will use anything that's already defined above it. And how we define spritesheet.js underneath Sprite.js, it would not be visible to Sprite.js file. And just keep that in mind when adding new components. At this point, let's go back for a second to our Sprite object and be reminded that the whole point of this tutorial is to replace our original counters here with a larger number of counters that are actually usable without breaking multiple animation counters when multiple objects are used. So let's go ahead and simply comment out these counters that are currently being used in a animation function. And all that we will do, we'll simply replace these animation counters that are being reused over and over again with a longer array of counters. In order to do that, let's start a new JavaScript file and call it animate.js. And within this file, we'll add some code. But first, let's also add it to our base code somewhere here, I would imagine. Animate.js. Going into that file. And in this file, we'll create our animation object, just like we created all other objects for our engine so far, using a JavaScript function constructor. Now this constructor will take 3 parameters, and which are incidentally the 3 counters that we're looking to initialize. Animation delay, animation index counter, and animation current frame. So these are the 3 counters that we discussed, except now we're putting them into a separate constructor for animate object. And within here, we'll simply create copies of those values. So this will be passed to here. Animation index counter will equal this value. Current frame will be equal to this argument here. And that's pretty much it for our animate object. Notice that it only contains the 3 counters, and that's all we need. Some of the other variables that we need to define are animation counter index, which is the global counter that will progress our counter down the array that we'll be creating. And it starts with 0. This is the actual animation counter array. And notice that we're not using animate object here because we need to use predefined array object, because it's really not an array of type animate. It's an array of type array. And within this array, we'll have a bunch of objects of type animate. So let's go ahead and initialize that. In order to do that, we need to create a function. Initialize animation counters. Pretty simple name. And within here, we'll use a for loop. And we'll go up to 32,000 counters, as we discussed earlier. You can change that later to adjust to demands of your game. And here, notice that I'm using the array animation counter here and assigning 32,000 entries of animate array. And we'll use the constructor here. And at this point, we're simply only initializing. So that means we can set all 3 counters to 0. And finally, we'll need a function that resets the global animation counter index on every frame. Reset animation counter. And it's as simple as taking this and setting it to 0. So that's really all there is to it. And we already have animate.js included in our base file. So now let's place these functions that we have just created in a proper placement. Initialize animation counters should be placed where we initialize all of that generic stuff before the game even starts. So this would be a good place. And animate reset animation counter. Well, we need to do this every frame so that we'll always start with a 0 index in our animation counter array. So that's where we will do it. Let's browse down to our game loop. It's probably a good idea to do it as the very first thing in the frame. This is definitely proper placement for this function. And again, the reason for this, on every frame we reset the counter to 0. So every time we draw sprites with these functions, we always start with 0. It never goes out too far. We do have 32,000 counters, and we'll take 32,000 calls to the dog object to deplete that. And that probably will never happen. And if it does in your game, if you have so many objects, all you have to do is simply increase the number of counters that we created. But I do think that 32,000 is a pretty good number at this point. In most cases, probably 95% of the time, you will not even be using that many objects. So you can always reduce this to, let's say, 320. And that will save some memory. But I'll keep it at this point for now. I refreshed the browser, and as you can see, it broke our current animation code, and that was supposed to happen. Our sprites are loaded, everything is working fine, but let's look at draw animated. Remember that we commented out all these definitions of these counters because we're changing them, and they no longer register in our sprite object, and for that reason our dog here stopped running. And what we need to do is we need to adjust our sprite object and write a completely new function that is pretty much very similar to this function, except that it will use our new counter array that we have just created in the previous step. Now, I'm not going to touch these older functions from tutorial 7 in this tutorial so that we just don't mess them up. But I will take all of this code and rewrite the counters. And in order to start doing that, I'll simply go and create a new draw function. First, I'm going to clean up this a little bit, and let's just say that this is an old version. So we get rid of that. And let's start a completely new function for drawing sprites, which will take exactly the same parameters, x, y. But there's one more thing that I would like to add here, and I'll add a parameter called various, and I'll explain it in just a second. Before we move on, I really need to mention the concept of overloading JavaScript function. And the concept of overloading functions really comes from C++, and truly it doesn't really exist in JavaScript. For example, let's say we have something like this in C++, and it's all about using the same name for functions that have a different body. And it usually works when there are different types of parameters, or a different number of parameters is used in a function with the same name. In C++, this would be totally fine, and each function would have its own body that's completely unique to each one of these functions, even though the name is the same, strictly only because the number of parameters is different. And doing it this way is called overloading a function. In JavaScript, however, that's not the case, and defining multiple parameters for the same function will result in the previously defined function by the same name being completely overwritten with the new one. So you will not have the same function just because you have different number of parameters. That's just not how JavaScript works. But wouldn't it still be nice to use the same name for JavaScript object to draw something on canvas using the same function, seemingly? And the answer is yes, it's possible. In order to do that, we need to approach our function construction in a certain way. One difference is that we're not going to be separately defining each function with the same name in JavaScript. Instead, we'll define only one function, and based on certain conditions, a different part of that function will be triggered. So in a way, it's really a lot like overloading functions in C++. However, we need to do some manual work in order to achieve that functionality in JavaScript. And that's really the whole purpose behind the parameter called various. So based on whatever is being passed into that parameter, will change the way our function works. Notice that this function can be used with only 2 parameters passed to it, and that will mean that various will equal undefined. So JavaScript does to a certain extent support function overloading, just not as good as C++. Or at least you can interpret it that way. And having said all of this, I think we are now ready to start constructing our new draw function. And we'll start by drawing our regular sprite, just like in our older example. And that's really just a copy of this here, our older version. But we'll start with creating a new branch. And let's check if various is undefined. In other words, if it's not passed into this function, we'll simply use our old code. And let's create an else statement. Let's create our second case where if various is a single numeric frame ID. And let's create a if statement for that. jQuery has a function to check if a variable contains a numeric value, and it simply is numeric. Let's check if various is a numeric value, and also let's check if various is equal or greater than 0. This will give us a frame to work with. In other words, a single frame from the image source, which usually is a sprite sheet. And the way we will process this, first we can use a older function as a reference, where we used an older function i2xy to convert index-based frame into a sprite sheet grid, and that's the function that we will use here as well, except we will pass various itself into that function. So here we're creating XY position from the sprite sheet that has been loaded. And in the same way, if we go down here a little bit, we'll simply copy and paste this and place it right here. Again, remember that all of this assumes 32 by 32 pixels sprites in the sprite sheet. If yours are different, you have to change these values here as well. And again, 8 is the number of rows and columns in the sprite sheet. And if you have a different number of sprites aligned in your sprite sheet vertically and horizontally, you should probably change this value too. But for these tutorials, we're working with a standard 8x8 sprite sheet map. And finally, we're going to cover the third case where an animation sequence is passed into the various variable. If various is sequence, such as an array like 1, 2, 3, 4, or 17, 18, 19, 20, or any sequence really. It doesn't really matter, as long as the index values within this array fall within our sprite sheet somewhere. The if statement for that would be various. When we pass an array into draw function, we know that in JavaScript arrays have property length and most other objects don't. So if we check for that property, if it exists or doesn't exist, if it's not undefined, that means that it exists. And various length is greater than 0. So at this point, we're pretty sure that it's not an empty array and that it is indeed an array. And so we can do something like this. And within this code right here, we'll simply copy and paste from our previous animated function. And we can just take all of this and copy it into our if statement right here. And remember that because our animation sequence array is now stored in various, in this case, we simply need to replace these parts as well. So we're looking up in the correct place for those animation frames. Now, this is not going to work because remember, we're still using old counters, and the whole point of this tutorial is to convert them to the animation counters that we created earlier in this step. And let's take a look. We created an array called animation counter, which includes all of these 32,000 entries. And we're going back into Sprite now. And we simply need to convert all references to this variable here to our array that was created. And we're going to go ahead and do that. But before we do, remember that we also have animation counter index. So, and it's always reset on each animation frame in our game loop. So really what we're going to be accessing is this counter index, and it's going to look like this. So let's copy that from here. Again, we're using this array and we're using an index on it, which is being reset on every frame. And we simply need to plug this into this part. So I'm going to go ahead and do that and replace all instances of this with our global animation counter index. And there's one right here. There's one also here. And so we have just successfully plugged that in, and now we have dynamic counters for all of our animations. And at the bottom here, I would say, remember that every time we draw with the draw function and we're drawing an animation, we need to increase the counter so that we move on to the next one in the array. And that's simply done by increasing our global counter. And so this finalizes our new animation function. We have just successfully plugged in a potential of 32,000 counters into our draw function. So every time we draw using this function, our animation counter index will go up. So these counters here will be accessed at that animation counter index rather than using the same counter over and over again, which is what used to break our animations in previous tutorials. This tutorial is already getting pretty long, and so what I'm going to do here, before I started recording this tutorial, I created an extra function, anim, and as you can see in this instance, it's still using the old counter. So what I'm going to do is I'll simply copy and paste what we have just done here and replace it with this. And in the same way, I'll take the animation counter, copy and paste it to the end of this function as well. And so what this function does, it animates the sprite in the same exact way as we have just explained here, except it also rotates it around an axis. I did have to create a separate function, although we could probably later plug this into as one of the various parameters and just branch off with another if statement right here. But for now, it's just a separate standalone function that will allow us to rotate our sprite and animate it at the same time. The only thing to notice here is that we're using some generic JavaScript context canvas functions to translate the sprite to its center, then rotate it. And then we draw the image and we translate the sprite back to its original position. Doing it that way will rotate the sprite around its center, which is 16 by 16 pixels, because our sprites at 32 by 32 pixels in the demos throughout these tutorial series. And again, if yours are different, you do have to change these values around a little bit. As the last step here in Sprite object, I'll simply remove our old draw animated function that no longer serves any purpose. And this will clean the Sprite object a little. And now I'll go back to our main file for the game, and this has been using an older function, draw animated, that's no longer there. So I'll simply replace that with our new function, draw. I'll resave that and refresh the browser. As you can see, our dog is successfully being animated, and I assure you that it's using one of those 32,000 counters. Another very interesting point here, and a huge difference from our previous example, is that now that we're using the same object dog, let's just try to display it at a different location. Let's see what happens if we use the draw function in the same way again on the dog object. Let's refresh the browser. You will see that there are two dogs and our animations no longer clash, which is a huge progress for our animation engine. And what's more, we can continue using this object just like that. And let's see here. Let's say 96, 96. And instead of animation sequence, let's try to use a single frame. And let's use the first one in the sprite sheet, which is 0. I'll resave this, and as you can see now, not only we can draw animated sprites, but we can also draw static sprites. And I think this is really great improvement over the last version where all of these animations were colliding with each other and there was no one uniform way of drawing, and now there is, and it's super simple and convenient. For example, also let's try to use our other sequence here from 17 to 20, resave that, and let's watch what happens. So we have multiple animations going here, multiple objects, all possible to create with the same instance of the same object, which is what we were trying to do all along. And I know that all this code in this tutorial has been a little more complicated than our usual code, but the results are really speaking for themselves here. And let me finally try to use a rotated function and see what that does. You can use it on the same exact object. I would say let's 32, 32, and the sequence 1, 2, 3, 4. Rotate angle, let's use dog rotate. It's not defined yet, but we're gonna do that right now at the very top of our code here. Let's define the angle, and let's, on every frame, let's increase that angle. Resave and see what happens. Nothing happens because various is not defined. That should be easily solvable. We simply need to replace various here with sequence, because that was the name of that parameter in this function. And we're going back to here, refresh. Still nothing happens, but we'll fix that in just a second. I just noticed it was because we're still using an old counter here, and we can fix that by fixing this up a little. Let's resave that. That was just a simple mistake I made earlier. Let's go back to here, refresh, and exactly as we thought, the dog is animating and spinning at the same time. And that's a pretty cool effect. So notice how we have all these different ways of drawing sprites now, and this will really help us a lot in moving forward. And there's just one more thing left that I would like to explain. remember how we created a sprite sheet object, and so this now enables us to create sprites in a completely new way. For example, let's create a new sprite sheet. Notice that we're not creating a sprite in this instance. Dog sprite sheet.png. And let's create another sprite, dog3 new sprite, but this time instead of passing a file name, let's pass the sprite sheet itself that has just been created. And again, we only have to do this once. We can create as many dogs as possible, as many as we need using the same sprite sheet. Notice that we're no longer loading the picture over and over again into each sprite. It's cached here in one variable. So let's grab dog number 3. Let's go down here. And again, when sprite is created in that way from a sprite sheet, all of the same functions will apply to that object. And we can use it regardless of how we created it. Let's try this out. Let's say I want to draw this dog 100, and let's see what happens. And it's an entire sprite sheet being rendered there. And actually, let's apply this function on it. And again, it's creating a rotating dog there. One last thing is, remember that we also have, in previous steps, we created a rotated draw. And I'm just experimenting here. Let's try this out on dog 3. Rotate angle, dog rotate. And as you can see, we can even rotate an entire sprite sheet or whatever the image was, but this just to show you an example. And maybe another dog 3 with a different angle at a different position. So now we have 2 sprite sheets rotating right there. And as you can see, we have some pretty good means now to draw sprites in all kinds of ways. And I think at this point I will conclude this tutorial, and in our next tutorials we'll actually focus on game development a little more now that all of these complex programming is behind us. So I hope to see you guys there, and thanks for watching my JavaScript game development tutorial. You have just watched another installment of game development tutorials by Dev Tigris. That's me. If you want to be reminded when my next tutorial is out, you can do so by subscribing to my YouTube channel. This is usually done by clicking on the subscribe button right underneath this video. I appreciate everyone's time, and I'll see you in my next tutorial.